But it is my pleasure to talk to you today about a project that Alberta Agriculture has been working on. We're hopeful that this project can really help in the watershed planning and the management of agricultural watersheds in Alberta. As we all know, or should know by day 2 of this conference, watershed planning is the land use planning that recognizes the watershed boundaries and considers water management as the central objective. In Alberta, here we're using the Water for Life strategy and the land use framework to work on a cumulative effects approach. And we recognize that water quality targets will likely be implemented through this process and that agriculture will be expected to comply. We also know that agriculture is perceived to be a fairly large polluter to the environment at times. So at Alberta Agriculture, we've been working to understand what the real impact that we're having on the environment. And the ASA water quality monitoring program that we did monitored 27 watersheds throughout the province. And we found that as ag intensity increases, water quality degrades. We also did a soil phosphorus limits project where we confirmed that indeed phosphorus in the soil is directly related to phosphorus in the runoff. So we can say that yes, agricultural practices do have negative impacts on water quality. One of the recommendations that came out of the soil phosphorus limits project was that we need to be working to develop, demonstrate, and test beneficial management practices. And we've done this very well. We have all kinds of manuals and fact sheets. They're all available on our websites for pretty much every agricultural operation out there. The piece that we haven't really done great on is the testing piece. And people are asking which BMPs are the most effective, how much do they cost, if I have X amount of dollars, tell me what I should do to get my biggest bang for my buck. So that led us into the project that I'm going to talk to you today about. So we've had a lot of support on this project. Mostly, well, everyone helps, of course, but the Alberta Crop Industry Development Fund was the person who, or the agency that provided most of the funding for this project. And Alberta Environment also helped, and AESB, also the MD of Pincher Creek and Lacombe County, which we were working in those watersheds. And the biggest one that I want, or the second biggest maybe, or equally as big one I want to identify is the producers in the watersheds that really let us come in and work on their land and communicated with us. And we wouldn't have been able to do the project without them. So this project's name is the, get ready, Nutrient Beneficial Management Practices Evaluation Project. So it's quite a mouthful. We usually just shorten it down to call it the BMP project. It was 6 years in length, and it involved working in 2 watersheds and also 2 field sites that we chose. We spent 2 to 3 years of monitoring the current practices in these watersheds without making any changes at all. And then we went in and implemented the BMPs, and we continued the monitoring for a couple of years post-BMP to evaluate the changes that might be happening in those watersheds because of the BMPs that were put in. We monitored water quality in stream, both upstream and downstream of the BMPs, and we were also monitoring at the edges of the fields where the runoff was coming right off the field before that water was entering the creek. So the first watershed we were working in is Indian Farm Creek Watershed, which is down in the south. It's quite close to Pincher Creek. And the other watershed was up here in central Alberta, quite close to Lacombe. It's officially called a sub-watershed because we were just working in the bottom half of the watershed. And our 2 field sites were just north of Lethbridge in the Little Bow and the Battersea Drain watersheds. So we had 18 BMP sites in total in all those yellow areas there, which involved 55 water monitoring stations. So we have a lot of data. In addition to the water data, we are also collecting information on range health, riparian health, all kinds of parameters that we could think of, because we really wanted to make sure that we were able to see changes in these watersheds, even though it may not be completely reflected in the water quality. Maybe some of these other pieces we would also be seeing changes that we could relate. So I'll just spend a little bit of time contrasting the two watersheds, because they are in different ecoregions. So this is important to recognize, because the BMPs the issues that you're needing to address with the BMPs are likely different because of the different ecoregions, and also how you're evaluating the success of the BMPs. You need to consider the ecoregions that the BMPs were implemented in. So the Indian Farm Creek watershed is in the fescue grassland ecoregion. It is, as you can kind of see from the picture there, it is a deeply incised and highly eroded creek. There is moderate ag intensity in this watershed, and it has some beef and dairy operations and quite a strong cow-calf component. The watershed itself is about 60% pasture, so that really supports that cow-calf industry there. And runoff in this watershed is mostly rainfall. This is a hydrograph of the 6 years of the project when we were working out there. As you can see, or maybe see, that we experienced the two extremes. We had some very dry years, and we also had some very wet years. But what is most interesting, I think, or important to notice with this, is if you cut this hydrograph in half, you'll see the 3 pre-years and then the 3 post-years. And you can notice that we did have similar years in both the pre and the post. So this is really important when it comes time for evaluation, because you need to compare similar years. So you need to compare the dry years in the pre to the dry years in the post, and wet years in the pre and wet years in the post. So we were very happy that even though we had extremes, we had similar years. Whelp Creek watershed is in the parkland ecoregion, so it has more trees and more wetlands. It's very different from Indian Farm Creek in that it is a very shallow, undefined creek. I'll just mention, it's actually so shallow in spots that when it dries up in the summer, farmers, producers, they just work right through it. There's nothing to stop them from doing that. It is a high-intensity watershed, and when we started the project, it had dairy and hog operations. There are no hog operations left now because of the way the hog industry went, but the runoff in this watershed is mostly snowmelt. And so this is a similar hydrograph of Whelp Creek. You can see we experienced the same extremes, but what is kind of tough and very challenging is if you draw that same line kind of halfway, you'll see that all our dry years were in the pre and all our wet years were in the post. So this has made it quite challenging when it comes to trying to evaluate these BMPs. But it's the climatic variability that we kind of knew we would likely have to deal with. So we implemented quite an array of different BMPs here. Usually at a BMP site, it wasn't just one BMP. There was usually a couple of things that were all implemented at that site. We thought that was likely wise to maximize our chances of seeing any changes because of those. So now I thought maybe I'll just step you through a couple specific BMP sites to just give you a flavor of the kind of work that we were doing. So this is the pasture site. It's in Indian Farm Creek, so down in the south. It was 2 quarter sections that had the creek running directly through the middle of it. There was also a bit of a drainage area that would drain the pasture down and into the creek. This pasture had an old corral location that the cows really liked to, even though the corral itself wasn't officially used anymore by the producer, but the cows really congregated around it and really liked to use it as a wind shelter because, as some of you may know, it does get kind of windy down in Pincher Creek. Unfortunately, the location of this corral was that all of the runoff from it drained right down into that lower area and went right into the creek. The cattle in this pasture also had direct access to the creek, and there was some significant stream bank erosion and riparian degradation that we noticed. So the things that we worked on at this site were that when I say we, because it was us and the producers were greatly helpful in making some of these changes. We removed the old corral completely. We implemented some grazing management, which was rotational grazing. So it built some fences, provided a watering system, so this producer could have smaller paddocks that he could rotate the cattle through, and provided some windbreaks to kind of replace that corral that we moved. We also did some bioengineering to try to address the stream bank erosion. And this was a project that the Watershed Stewardship Group actually took on. They applied for some funding, and they received some money from the Alberta Stewardship Network. So they went ahead and did this bioengineering. The total cost of this BMP was just under $16,000. The results that we're seeing was that we saw a significant improvement in the water quality at the edge of field site, which we're very happy about, and we think made a lot of sense because just so you can see those two pictures there, that's the corral site. So there was, a significant improvement there after we got rid of it. So that's what we're attributing those results to. Unfortunately, we didn't see any differences in the main stem water quality, and we think that's because the improved water that was coming off of the field was such a small amount in volume compared to the volume that's in the main stem. So it doesn't mean that better water wasn't having an effect on the main stem. It just means that the effect was likely so small that we just couldn't measure it. We also saw a big improvement in the rangeland and the riparian health, which we think is because of that change in grazing management. So now moving up to the Whelp Creek watershed. Our Northfield site was a little bit similar to the pasture site. It was a quarter section that had the creek running right through it. It had a dairy operation, and the most of the quarter was all cropland. It also had a lower area that was draining the field runoff down into the creek. So this producer had no nutrient management plan or any manure setbacks, and he was storing some of his manure quite close to the creek, which we thought might be causing a problem. And there was also a lot of disturbance through the drainage area off the field where he was driving his machinery back and forth through, and it was causing quite a bit of erosion. So the things that we worked on with him was we helped him to develop a nutrient management plan so that his manure could be applied based on the crop requirements. He started injecting his liquid manure instead of surface applying it. And he also, the green lines there we also implemented some manure setbacks. So he couldn't apply manure within, I don't remember, 30 meters or something of the creek. We moved his manure storage away from the creek. And we also installed a culvert and a gravel crossing so that he could use for his machinery to get back and forth across. So the cost of this BMP was $2,800. Now the results at this site are a little bit harder to interpret, and I'll try to walk you through them. I think it's important to illustrate sometimes our results are not as cut and dried as we would like them to be, so that's just kind of what I wanted to show with this. We did see a significant reduction in total suspended solids at the edge of field. We think that's likely directly because of the culvert and crossing that was put in. We also saw E. coli concentrations at the edge of field decreasing, which we thought, well, maybe that's also because of the culvert, because E. coli and total suspended solids can be related at times. We're not completely convinced, though, because most of the other water quality parameters at the edge of field site actually got worse in the post years. This isn't hugely surprising to us because if you remember the hydrograph, we had all the wet years in the post, and wet years usually mean more runoff, and more runoff is usually poorer water quality. So our The main stem water quality results were quite variable. At the downstream site, we actually saw an improvement in some of the water quality parameters, which again was kind of puzzling to us because of what I just said of the post years being wetter, so we would have expected things to be worse. So we went and when we compared it to the upstream site, we saw the same trend, that things were actually improving in the post years. So we knew that we couldn't attribute that to the BMP, because if it was because of the BMP, we would only be seeing those results at the downstream site. There is a wetland above this site, and one of the things that we started noticing at some of our other sites that also had wetlands were that after the wet years, there seemed to be a bit of a flushing effect that happened, that those wet years kind of flushed some parameters like nitrate or chloride kind of out of those wetlands, so we were seeing decreases in those concentrations, and that has been noticed in some other studies. So that's what we think that reduction downstream is from. So kind of tough to navigate through, when we're seeing these results, we're kind of scratching our head sometimes trying to figure out what's causing them, whether they're related to the BMP or not, and so yeah, it is kind of challenging sometimes. We are just in the stage right now of compiling all of our data and analyzing it and looking at it. We're hoping to have our final report done by June, so none of our final conclusions are really final yet, but I can share some general conclusions of the things that we're seeing. As I just alluded to, our results are variable. We are seeing improvements at some sites and not other sites. So that's interesting for us to try to figure that out. It's not a surprise to us that the climatic variability sometimes interferes with the pre and post BMP analysis. We can say that grazing management has had a positive effect on the riparian and rangeland health. One thing that kind of surprised us was that we found that the livestock BMPs were easier to implement than the field nutrient management BMPs. So that was kind of a learning for us. And one of the most important conclusions, I think, is this last one that just says that building relationships and making changes does take time. I'll just share one of the things that I think is illustrates one of the biggest successes of this project was that we started working in these watersheds. We helped each watershed set up their own watershed stewardship group, and we were continually telling them, if anybody has any ideas about any BMPs that we should be working on in this watershed, bring it forward, tell us, because who knows the watershed and the operations better than the producers themselves, and so we were telling them this and nothing. We never heard anything, and it wasn't until year 4 that people started to come forward with ideas, and we were able to implement 5 new BMPs at that time that were ideas that had come right from the producers. So it just goes to show you that it really does take time to build those relationships, and people just don't believe, I'm here from the government and I'm here to help you. It just doesn't, they just don't buy it till they've seen you out there working and helping them, and then eventually it starts to come. But it's a really important piece as we're trying to move forward and make these changes, to not get frustrated if the changes don't seem to be happening really quickly, because it just takes time. So, and along the same vein, I guess, we're not naive enough to think that after 2 years we would expect to see these great changes in water quality. It's not completely reasonable. Unfortunately, it's really hard to get people to fund a 20-year project for you. So we have to do what we can do in the time frame that we're in. But we are very optimistic that the changes that have been made in these watersheds will likely continue to cause improvements down the road. We just may not be able to monitor them, but I think the groundwork is laid to keep moving forward. So I'll just, this is my last slide, just to tell you a little bit about a new project that we're working on. It's a Phosphorous watershed project, and the focus of it will be on phosphorus and livestock. We are planning to intensively hit a smaller watershed with a lot of BMPs, with the hope that we can see more changes in stream. We're very excited to have some industry involvement in this project because we're working with the Intensive Livestock Working Group on this. So that's kind of exciting to have them standing beside us as we're going forward and trying to make these changes.